All right, welcome, welcome, welcome. We're going to do some math, your favorite subject, of course. Welcome. Let's do some past papers. We are talking about the coordinate geometry, your favorite one again, and some C1 math. Let's roll. We got an equation with 2 points A and B, and they want us to present this in form ax plus by plus c. All right, we're going to talk about that one in a moment at the end, but it is important. And all the values, they need to be integers. Integers are whole numbers, plus or minus whole numbers. I can't spell, but there you go. How can we resolve this little problem, you may ask? We got 3 marks here. That means we have to show some workings out, right, to get those 3 marks. Now, when you look at math, essentially, a lot of the times there are formulas. There's one formula I would say you need to know. Your house is on fire, and they come and wake you up in the middle of the night and tell you what is the formula, what is the equation of a straight line, and you tell them it is y minus y1 mx minus x1. Here you go. All right, you always need to know this formula if you want to do well on your A levels or IB. All right, let's do this. So first of all, let's look at the things that we have versus the things that we are missing. That's how you really should approach math, really, and it's gonna make it more easier for you. Y1 and x1. This is the coordinate. All right, so we have that. We have it more than we need because this is one coordinate, and we are given 2 coordinates. We have A and we have B, so we can pick any of them. All right, next is M. M stands for the gradient. All right, for the gradient. Now, in this case, how can we find the gradient? Sure, there is a formula for the gradient. I can show you that, which is you take y coordinates, subtract them, and you subtract the x coordinates. So there's a difference in y divided by difference in x. I don't really like formulas, so if I can avoid formulas, I will do that. So I do like drawing stuff because I have this nice little iPad here, so I like to do that. All right, so I'm gonna put a 7 and 4 a little bit at the top here, and my B will be here at the bottom. Actually, let's put B over there, because I'm gonna write there. All right, so this is the line. Obviously, your line goes through that. It doesn't just start and stop at N and B, but it just goes through those points. Now, since the gradient is difference on y and difference divided by difference of on x, I'm going to try to find out what is this distance. So when I look at the y distance, I go, it's here from 0 to 4. So I know this distance is 4. Now on the x-axis, I go from 2 to 7. So now that distance is 5. Therefore, my gradient, m, will be 4 over 5. Now you can use the formula and check it. 4 minus 0 and then 7 minus 2, and you're gonna get the same thing, 4 over 5. So up to you. If you are the formula person, use the formula. All right, so what else do we need to do? Okay, so here let's just put stuff in the formula now because we got everything. So there we go. So I'm gonna write the formula one more time because I am a strange person. All right, and I like to write formulas. So what do I have? Y1 is my y coordinate, right? I'm just gonna use this coordinate because 0, 0 is great. Cancel things out, right? It's nothing. And then I'm gonna use this for 2, and the gradient was 4 over 5. Now you can use 7 and 4. Actually, check it. use 7 and 4, see if you're going to get the same answer, because you must get the same answer. Math does that thing. All right, so I'm filling the blanks, and this is essentially what I have. Y minus 0, y minus nothing is that. So I get 4 over 5. Now, I could expand the bracket, but guess what? I won't do that. I'm going to multiply everything by 5. I'm teaching in international schools all over the world, so I really right now don't remember if I should do just times or dot. Different countries, there are different things. So I just mentioned this is multiplying by 5. All right, so when I multiply by 5, I get 5y equals 4x minus 2. And now I'm going to expand the brackets. Expand. Now when I expand the brackets, don't forget I'm multiplying everything in front of the coefficient in front of with all the terms inside. So I get 4x minus 8. Now, this is where I go back to this over here, this form. Now, students do like to lose mark, that one extra mark at the end for the A1 mark for accuracy. Now, if your AX, so if your coefficient on A is not positive, you're not going to get full marks. You have to have a positive AX. This is what they say. And your values, they have to be integers, whole numbers. You see, that's the reason they say it, because your gradient is 4 over 5. And we hate this looking like that, right? Just disgusting. Less disgusting than decimals, but nevertheless disgusting. All right, so what we want is this. Your intuition will tell you, your education in school, hopefully, there are positive and negatives, but will tell you that you should move from the right side to the left side, right? Which in this case is minusing 4x and adding 8, right? This is equation, so we do the opposite. Okay, it's to what we have. We have plus 4x, we're going to minus 4x. We got minus 8, we're going to plus 8. But if we do this, you're going to end up with a negative 4x. So I'm just going to switch the sides. I'm going to write 4x minus 8 equals 5y. I can do this. Apples, bananas, bananas, apples, right? Same thing. All right, and now I'm going to move the 5 to the other side. So I get 4x minus 5y minus 8 equals 0. And now this looks like what they want. They want A. This is my A, X, B, Y, and C. My B is minus 5, my C is minus 8. All right, so this is question A. All right, let's separate this. I'm gonna try to fit everything on this one page. Well, that's not gonna happen. Okay, so B. Find the length of AB, leaving your answer as surd. All right, surd is peculiar. All right, we got roots. Maybe I shouldn't draw the arrow here. Actually, let's do 2 arrows. We got, but from surd, okay, never. We got roots, right, which are like 16 square roots. That gives you nice, lovely answer. But we also have things like root 20. What do you do with that? Well, root 20 is 4 times 5, which simplifies to root 4 times root 5, which is 2 root 5. Now, things that cannot be like nicely simplified, those are the roots, like root 17, right? What do you do with that? Nothing. You just put it in a calculator and get absolutely disgusting decimal that we hate. So those are the surds. All right, this is what we're expecting to get. We're expecting to have something like root 17, something or something like 2 root 5. By the way, my root 5 here looks like 3, but you know, you understand English. So let's roll with this one, guys. Let's roll. Let's not waste time. B. Yeah. So okay. So we had this drawing right over here. And I remember telling you, because it was in this video, that this distance was 4 and this distance was 5. Now, If we want to find the length of something, we simply use Pythagoras, right? All of you know Pythagoras. For my Chinese students, it's called Gogudingli. You all know a squared plus b squared equals c squared. So you know this is your a, this is your b, this is your c. Yeah? All right. So let's just do that. Let's just do that. 4 squared plus 5 squared equals c squared. Bear in mind, c in this question is called AB. Yeah? So I'm just going to say it properly. AB squared equals 16 plus 25, which is 41. And therefore, we need to square root that, square root both sides, and we get 41. So AB is 41. Square root of 41, obviously. Now, that cannot be simplified. It's just a surd. Now, when we go and do differentiation, and we're going to do some pre-algebra stuff to do differentiation, things like indices and surds, you're going to have to be really good at that in order to do differentiation calculus. What you see right now on the screen is Desmos, right? So I'm representing all this on the graphical calculator, which basically what it is. Suggest you download the app if you are a massive nerd. Okay, so there we go. We now going to, we are told, right, going back to that question, we are told that the AC and AB are the same. What does this mean? It means that when I have this coordinate 2 and I have this coordinate here at 7, 7, 4, right, there is an extra line there, and this line are the same. Those two lines are equal to each other. So what does this mean? It means that this coordinate 2t is on this line over here. All right, on this line, I'm going to draw this line, x equals 2. Let's put this line over here. So this coordinate is somewhere on this line. Now, since the line A and B is the same as line AC is the same, is equal, it makes it isosceles triangle, which means there is a line in between. Now, the distance of that line from 0 to our coordinate 4 over here, right? We got 4, so that means the other line, other coordinate, rather, must be at 8 over here. Okay, and to demonstrate this line over there, here, that distance is 4 units because it goes from 0 to 4. That means this line has to also be 4 and be 4, and then 4 plus 4 gives us this coordinate 8. Therefore, point C is 2, 8. Okay, and now we have also a last situation, which is this triangle here that we now know is isosceles, meaning this length and this length are the same. So what we're going to do is, for obviously area of a triangle, we need half base times height. Our base is here, 8. Our height is this distance over here, which goes from 2 to 7, which means it's 5. And half times 8 is 4. 4 times 5 is 20. So we got 20 units squared is our answer, and therefore we tick all those answers. All right, let's move on to question number 2 on next one. Let's roll with this one, guys. Okay, so we got a line L has this equation, and we need to find the gradient of that line. Now, gradient, many students think the gradient is always a number in front of x. it is partially true. Gradient will be a number in front of x as long as y is the subject. So first thing, we need to make y the subject, which means all those terms over here, we need to move them to the other side, keep my 5y positive, and then get rid of that 5. All right, so that's what we're going to do. We're going to do 5y, and then when I move the 3x to the other side, is minus 3. I move it 2, becomes plus 2. Well, essentially, I'm adding 3x and I'm minusing 2, right? And now I'm going to be dividing things by 5, and I get 3x over 5 plus 2 over 5, but I'm interested only in this number over here. Minus 3 over 5 is my answer. That's the gradient of L1. Okay, so just remember that it's always a number in front of the x as long as y is the subject. Okay, now what they say is that line L2 is perpendicular to L1 and it passes through point 3,1. Okay, so just to imagine how this would look like, I can draw this on Desmos. So here I'm going to make it a little bit bigger. There. All right. So now what this means, there was a word here, perpendicular. Perpendicular lines are your lines that they meet at 90 degrees, right? Meet at 90 degrees. All right, so L2, this is, by the way, this line here is your line 3x plus 5y minus 2 equals 0. So we got to this perpendicular line, this black line over here, that goes through this point, and it goes through here. Now, what this means, there is a special relationship between the perpendicular lines, and this is something you have to remember. Unfortunately, in math, there will be things that you need to remember. Now, perpendicular lines means that L1 times L2, maybe I shouldn't use the L1, maybe I should just do write gradients. Gradient of first line times gradient of second line is always going to be equal to minus 1. That is the formula for perpendicular lines, which means if the gradient for the first line was minus 3 over 5, then we need to multiply this by something that would give us minus 1. Now, obviously, that number has to be positive, and in order for this to be 1, it will have to be 5 over 3, just the reciprocal of that number. And if we multiply them together, it will give me minus 15 over 15, which is minus 1, right? So that means we are going to write this equation as y minus y1 equals x minus x1. Obviously, every time we're going to write this formula. And what do we have? Well, first of all, we know the gradient right now, right? We know this gradient. We know this value being 5 over 3. And we now need to figure out, is there any coordinate that we know that this perpendicular line goes through? Well, we do know this coordinate, right? It is 3 and 1, so we're going to use this coordinate. This is going to be my 1, this is going to be my 3, so let's write this now. Therefore, this is going to be y minus 1 equals 5 over 3 x minus 1, x minus 3. X coordinate is 3. Okay, we need to present this in this form where m and c are constants. So they don't say integers, they just say constants. All right, so we are just going to plus 1 for both sides to get that 1 on the other side, and expand the brackets at the same time. So 5 over 3 times x and times this one. So 5 over 3x and 5, that's going to give me, the 3's will simplify, and it will be 5 and then plus 1 because that will cancel, and we got 5 over 3x minus 4, and this is our answer for that question. And let's move to the last question for today. Sometimes when you do past papers, there's obviously crossover with other topics, and this is what we're going to encounter in this question. So this question, past exam question, says factorize. And now it says factorize completely. Completely meaning that there's no other possible factorization. If you somehow forgot what factorize is, let me remind you. So let's say you had 2x plus 4. This way, it's expanding. So you're expanding the bracket to 2x plus 8. Factorizing is going in reverse. All right, expanding one way, factorizing in the other way. In math, we have a lot of those doing, undoing type of situations. Okay, so let's figure out how we're going to tackle this question A, factorize. We got x to the power of 3 minus 4x. This one, clearly both of them have x in common. That's how you need to look at factorization. They have x in common. That's what we're gonna get out. So now I ask myself, x times what gives me the first term? And that must be x squared. And then x times what gives me minus 4x. That's gonna be minus 4. Now, this is the reason why they use the word completely, because right now I did factorize, but it's not fully factorized. I can still do something about that. Now, what I noticed over here is something called difference of two squares. Difference of two squares. Now, squares. There you go. My spelling is amazing. All right, difference of two squares is this situation when you have the same bracket, you're multiplying the same bracket, but the signs between them are different. This will always give you first one squared minus the second one squared. So in this case, all right, we have this x in front of it. There's nothing we can do with that. So what can we do with x squared minus 4? Well, this is going to be x minus 2 and x plus 2. All right, as you see, x times x is going to give me x squared, and minus 2 times 2 is going to give me that minus 4. The middle operations, this times this and this times this, is going to give you 2x and minus 2x, and it will cancel each other out. That's why we don't have that third term in the middle. All right, so this is the 3 easiest marks you will ever get in your life if this was your question on the A-level exam. There we go. AS, C1. All right, the next one, what do they say here? They say the point A has a coordinate -1 and the point B has a coordinate 3. and they lie on C. So, oh, wait a second. Uh, wait a second. We still need to sort out B. All right, so wait a second. There we go. Boom. So we need to sketch this. This is a cubic graph. I'm wondering if I'm going to keep this or if I edit this out. Right, so we got a cubic graph for B. There we go. Cubic graphs, we're going to use what we just have learned here. Now, cubic graphs, they are quite specific. They will either look like this, or they will look like this. And if it's like just x cubed, it will look like that. Well, ish. Kind of like like that. This is like a point of inflection. My drawing is terrible. But yeah, let me show you this on Desmos. What I mean by that, I think it's better. X to the power of 3 looks like this, essentially. All right, there we go. That's better. Now, get rid of this nonsense, and there we go. Now, when we have a positive x to the power of 3, the graph will start at the bottom and there will cross the axis 3 times. It's a cubic after all, right? Now, in most cases, there is something called repeated root, but we'll talk about that if we get the question like that. Now, there is also a situation when there's a minus x cubed or minus some number x cubed. This is where your graph will come down from the top and it will be like this. And the reason for it is because we have those kind of invisible tangent lines here, and those tangent lines, the gradient of that is positive. So it starts like that. When it's negative, those tangents, they look like this, and it is negative. So in our case, if we multiply all the x's, because we also have that already there, we know this value of x cubed is positive. So it's going to start at the bottom. But what are the values it's going to go through? Well, this is, remember, mathematicians are lazy. So we don't really write this properly. This should be written down as x plus 0, x minus 2, x plus 2. So we have a lot of those little shortcuts that we do. So this gives you a value solution of 0. This gives you a solution of x equals 2, as you can see, and that one gives you solution of x equals minus 2, because you're asking when is the value of this is going to be 0. If I replace this with 0, everything is going to be 0. If I replace this value with plus 2, then the whole bracket is 0, everything else is 0. And we have those because the coordinates here are 0, 0, right? We also have here 2, 0. That y coordinate is 0, and then we got minus 2, 0. Okay, so now we can sketch it. When it comes to sketching, there is a big difference in the exam when they ask you about sketching or drawing. Now, drawing, essentially, if they say that on the exam, well, that's unusual. But that just means use a ruler. It needs to be much more accurate. Sketching just means make sure your shape is correct and make sure you use all the key points. And the key points are where your graph cuts the axis. So we're going to start here, starts at the top, cuts through here and goes through this. And obviously the y-intercept is at 0, 0. There's no need for that. Sometimes the y-intercept is somewhere else. But that's, we'll get there when we get there, when we have a question like that. All right, so that was B, and then going to C. I was very eager to get to C. We got coordinates that lie on this graph. So somewhere here, where x is -1, I have a coordinate, and somewhere at 3, I have another coordinate. I don't know what is the value of that y coordinate, and this y coordinate, y2, y1. I don't know what are those y coordinates, right? This is my y1, and this is my -1, y2. Don't know what are they. I will find out. We need to find the equation of a line, which is y equals y1 equals mx minus x1, m being the gradient, that goes through a and b. Find the equation of a line that passes through a and b, giving your answers in this form. So essentially what they're saying is that there is a line that goes through those 2 points. All right. Now, my line is not just a horizontal line. I'm very, I would be surprised if this was just this horizontal lines, even though it looks like this. Just my drawing is terrible. But there you go. That's just kind of like the sketch. Obviously, you wouldn't put this on B. You would use the previous one. All right, so what we need to do, we need to basically figure out a one coordinate, and we need to figure out the gradient. So in math, ask yourself, this is the formula, ask yourself, what do you have? Well, right now, I only have x coordinate. I can use either 3 or -1. So I have this, but I don't have the gradient. I don't have the y coordinate. All right, so I need to find this. All right, so my first thing would be to just find the y coordinates. To find the y coordinates, that's going to be straightforward. We just need to input the values of -1 and 3 into my equation. So into the very first equation, y equals 3x, x to the power of 3 minus 4x. All right, so here it's that was x originally, but it's now -1 cubed minus 4 minus 1, and here it's gonna be 3 cubed minus 4 and 3. And all right, what is that? -1 to the power of 3 is -1, and this is -4 times -1 is +4. So this gives me 3. So now I know this coordinate here is 3. And this coordinate, 3 cubed, is 27 minus 12. That gives us a juicy little 15. There we go. So they are definitely not a straight line. I mean, horizontal straight line. They are straight line, but not horizontal straight line. All right, so there we go. I am going to pick a coordinate, this one, -1 and 3, because they are smaller numbers. All right, so now I have this. Now I need to find the gradient. Now, with the gradient, we've done this before. Let's put those coordinates to use. So I have this one coordinate, which is -1, 3. And there's another coordinate somewhere here. The line goes like this. And this coordinate was 3, 15. Now your gradient is a difference in y divided by x. So I'm going to draw that. I'm going to find what is this distance between those coordinates. So what is the distance? What is the distance between -1 and 3? on the x-axis? Well, clearly this is 4 units. So it's 4 units here. And what is the distance on the y-axis between coordinate 3, there's a 3 there on the y, and 15? Well, that's obviously 12. So this distance is 12. Therefore, my gradient is 12 divided by 4, which is 3. Now I know it is 3, and I'm going to now put all this in the equation. So y minus 3 equals 3x minus, and don't forget that there's a minus 1, which gives you a plus 1. I'm gonna move this minus 3 to the other side. It's gonna become plus 3. So it's 3 times x. 3 times x is 3x. This whole thing is plus 1. So 3 plus 1, 3 times plus 1 is 3. And another, this 3 gives me y equals 3x plus 6. And there we go. That's our C. So let's figure out what is a D. Now they say that this line AB, because they were called AB, right? Minus 1 was AB here. AB. They say that we need to find the length of that line. So we got obviously minus 1, 3 and 3, 15. And we also, I mean, we already know the triangle is 4 and 12, right? So we know this triangle that we created, right angle triangle, that was 12, that was 4. So we're going to apply Pythagoras. I'm doing this question. So a squared plus b squared equals c squared. 2 short sides, that's a, that's b, equals 2 short sides squared equals the other one squared. All right, so let's apply this. I am going to call this AB. So my AB squared is 4 squared plus 12 squared, and that gives you 16 plus 144. Now I do have this calculator over here that I have not used at all, just to double check over here. 144. There you go. And this plus 16 gives us a really nice 160. So now AB squared is 160. Therefore, B will be root of 160. We need to square root the AB squared. Remember, square root and powers simplify. They simplify because square root is essentially square root of a is a to the power of half, and if you put 2 in there, 2 times half is 1. Therefore, they cancel each other out. Now, what they say is that we need to have this needs to be something root 10. So we need to figure this out. How are we gonna do this? Well, so the easiest way to think about this, you always need to look for a square number if you want to simplify this, the root, the surd. And here is the best one is 16. 16 times 10 is obviously 160, and that simplifies into root 16. We can break them down actually like that. And this is 4, and this is root 10. And therefore, K is 4, and it is a constant. 2 marks.